Is mitochondrial dysfunction a cause of chronic fatigue syndrome? Imagine your body's energy factories suddenly not working as efficiently as they should. That's what mitochondrial dysfunction is all about. In the context of chronic fatigue syndrome, also known as myalgic encephalomyelitis, research shows that mitochondria, the tiny powerhouses inside our cells, often don't operate properly. These organelles produce adenosine triphosphate, or ATP, which is the main energy source for all cellular activities. When mitochondria aren't functioning well, cells don't get enough energy, leading to the deep, persistent fatigue that many people with chronic fatigue syndrome experience. Studies have found that people with chronic fatigue syndrome often show abnormalities in how their mitochondria produce energy. For example, tests on muscle tissue and blood samples reveal lower levels of ATP and less efficient energy production processes. This means their cells are not generating enough energy, especially when the body is under stress or exertion. This aligns with one of the hallmark symptoms of the condition, which is post-exertional malaise, where symptoms worsen after physical or mental activity. Research also points to issues with mitochondrial efficiency. Some studies have used specialized tests to measure mitochondrial activity and found that those with chronic fatigue syndrome tend to have more significant mitochondrial impairments than healthy individuals. These impairments can include decreased activity of enzymes involved in energy production and lower levels of key molecules like coenzyme Q10, which is essential for the electron transport chain in mitochondria. These biochemical changes support the idea that energy deficits are a core part of the illness. Genetic studies have looked into variations in mitochondrial DNA in people with chronic fatigue syndrome, but no specific mutations have been identified as direct causes. Instead, subtle differences in mitochondrial DNA may influence how well mitochondria function or how susceptible someone might be to energy production issues. It's also important to recognize that mitochondrial dysfunction doesn't happen in isolation. It often interacts with other biological factors like immune system irregularities and metabolic disturbances, making the condition complex. While mitochondrial dysfunction is a significant piece of the puzzle, it's not the only factor involved in chronic fatigue syndrome. The condition is multifaceted, involving various biological systems that may all contribute to the symptoms. The dysfunction tends to become more noticeable or severe during times of stress or illness, which can explain why symptoms fluctuate over time. Understanding the role of mitochondria helps explain why fatigue in chronic fatigue syndrome is so profound and persistent. It shows that this is a real biological condition, not just psychological. Ongoing research continues to explore how mitochondrial issues fit into the bigger picture of the disease, aiming to find better ways to diagnose and treat it. If you or someone you know is dealing with symptoms, it's important to consult healthcare professionals who can evaluate all aspects of health and tailor management strategies accordingly. Remember, each person's experience is unique, and a comprehensive approach is key to understanding and managing chronic fatigue syndrome.